Okay, now I'm going to share you a few homework questions for chapter 8. First one is question 38. Arrange the following atoms in order of decreasing atomic radius. Sodium, aluminum, phosphorus, chlorine, and magnesium. Okay. So all these come from periodic 2, actually periodic 3. Let's take a look at this periodic table. Sodium, aluminum, phosphorus, chlorine, magnesium. So for the element in the same period, as we move from left to right, atomic radius becomes smaller, right? Because the same period means the same share filled by electron. The only thing difference is the outer shell electron becomes more and more. So start the outer shell electron 1, then 2, then 3, 4, 5, 6, 7, 8. But in the same time, in the nucleus, proton number also increase. Since proton number increase, then attractive force toward the outer shell electron becomes stronger. So attractive force becomes stronger, then atomic size becomes smaller. Okay, that means the first one, sodium, is the greatest or largest in atomic size. Since this is decreasing order, that means put the largest size first. Then next one, magnesium. So first, sodium biggest, then second, magnesium, then third, aluminum, then fourth, phosphorus. Last one is chlorine. Okay, so as we move from left to right, proton number increase, then attractive force toward outer shell electron becomes stronger, then size becomes smaller and smaller. Okay, this is the first question. Second one, question 44. List these ions in order of increasing ionic radius. N3 minus, Na plus, F minus, Mg2 plus, O2 minus. So in order to compare the ionic size, these ions must be isoionic. Do you remember what it means, isoionic? That means these ions have exactly the same number of electrons and exactly the same electron configuration. How many electrons for this ions N3 minus? N nitrogen atom 7 electron. 3 minus, this means gain 3 more, so total is 10. Sodium initially 11. Sodium iron lost 1, so 10. Fluorine initially 9. Right? If you look periodic table, fluorine initially 9. Fluorine -1 means gain extra electron. 9 gain extra 1 electron becomes 10. Magnesium initially 12. Magnesium 2 plus lost 2. 2 lost 2 is 10. Oxygen initially 8. Oxygen 2 minus gain 2 more means 8 gain 2 more is 10. Right? So all these ions have 10 electrons. This means they are isoelectronic ions. Since isoelectronic ions, they have exactly the same electron, then compare their sizes only from proton number. So we compare atomic size or ionic size, 2 factors. First, consider electron. If more electron, then repulsive force is stronger, so larger size. If more proton, then attractive force is stronger, then smaller size. Since all these ionic size, all these ions have same number of electrons, same electron configuration, the only difference is proton number. Which one has largest proton number, then attractive force is strongest, then its size will be smallest. So increasing ionic radius, that means place the smallest radius first. So which one has largest proton number? Take a look at the table. So nitrogen proton number will not be affected by charge. Charge is affected electron only. Okay, so take a look at the table. Sodium 11 proton, nitrogen 7 proton, fluorine 9 proton, magnesium 12 proton, oxygen 8 proton. So clearly, magnesium 4 proton is the largest. So attractive force will be strongest. Then its ionic size will be smallest. So we place magnesium ion first because its size is the smallest. Place its ion increasing ionic size. This means the smallest first. Then what is the next? Clearly the sodium, 11 proton. What is next? Then the fluorine or fluoride here is 9 proton. Then next is the oxygen, 8 proton. Last one is nitrogen, 7 proton. So nitrogen, here's nitrite, N3 minus are the largest or biggest ionic radius. Okay. Next, 54. Two atoms have the same electron configuration. Two atoms. Let's say atom 1. Electron configuration is 1s2, 2s2, 2p6. While atom 2 electron configuration is 1s2, 2s2, 2p6, 3s1. And the first ionization energy of one atom is 2080 kilojoule per mole. And the other atom, first ionization energy is 496 kilojoule per mole. After you pair each ionization energy with one of the electron configuration, this pair this or this pair this. Okay, so first of all, do you remember what it means of first ionization energy? I1, this means first ionization energy is minimal energy needed to remove electron from an atom in gas state. And what does this number tell us? Smaller ionization energy means either to lose or to remove outer electron from that atom. In other words, is that atom is active in matter, either lose electron, right? Higher ionization energy means not easy to lose electron. Maybe you want to gain electron, right? Then compared to this, which electron configuration tell you that one either lose electron? Take a look, outer electron. So you lose electron always outer electron. Outer for this one is 3s1, 1 electron in 3s orbital. And this is 2, share 2 is outer, 2s2, 2p6. 2s2, 2p6, this is already full. This is a noble gas in group 8A, don't want to lose. And this outer is 3s1, this is a group 1A, alkaline matter, very easy to lose this electron. Okay, that means should pair this because the ionization energy is smaller, right? Then this one pair this. Not easy to lose this outer electron. Okay. Then next one, question 60. Which of these elements would you expect to have the greatest electron affinity? Number 60. Which of these elements would you expect to have the greatest electron affinity? This element, helium, potassium, cobalt, sulfur, and chlorine. You remember what we learned in class? So electron affinity, nuclear change for element in same period. But there is one trend for sure. So group 7A in each period has the highest electron affinity. So group 7A has the highest electron affinity in each period. So fluorine is the highest in period 2. Chlorine is the highest in period 3. Bromine is highest in period 4. And iodine is highest in period 5. And which one in this element from group 7A? So clearly, chlorine. So, no. So clearly among these elements, chlorine from group 7A, this one greatest in electron affinity. So by the way, electron affinity means minimal energy. Actually, this is energy released when an atom in gas phase accepts actual electron becomes negative of the energy change we define as electron affinity. Okay, you are required to practice the rest homework questions, and we will have quiz 8 in next class.